Okay, we have here today another interesting integral on the board. We've got the integral from 0 to pi of dx over 3 to the cos x plus 1. Okay, now I want to approach this the way I usually do using King's principle, but we're going to do it just a little bit differently. Let's just look at King's principle first and then we'll get started with this. Okay, now we have the King's principle over here on the board to the right. We can notice that this is just adding the bounds, a plus b minus x. So it's very easy to show this just by making a u substitution for a plus b minus x, and that's going to really get you from here to here with a few steps. And if you wanted more details on this, I did a video. It was called King's Principle, How It Works, Why It Works, or something like that, and I can provide a link in the description for that. So typically when doing something like this, I would do the u substitution, do the steps all the way up, but in this case I'm just going to use this principle. So you'll notice here our bounds are staying the same. So for our a and b, b is going to be pi, a is going to be 0, and then we'll just rewrite this. Now this thing here is our f of x. So when we do this in this function, all we need to do is substitute in for x with a plus b minus x. So I can do that. So here for 3 cosine, I can write this as a plus b minus x here. That's just going to be pi minus x. And we have our plus 1. But then the nice thing here is cosine of pi minus x, we can transform that using the supplementary angle formula. So we have our supplementary angle formula over here, and of course we don't really need the sine one here this time. I just thought I'd write it out, just noticing that sine stays the same, but cosine we just get this minus sign. So we'll just rewrite again, and all we need to do here is this 3 cosine pi minus x is going to become 3 minus cosine of x. And so notice at this point we've got something really similar to what we had in our original integral, but we just have this minus sign here. Well, I think I can actually correct that. What I'm going to do is I'm just going to multiply the numerator and denominator by 3 to the cosine x. When I do this, we're just going to have 3 cosine x in the numerator here. Now I'm going to distribute this in here. This first term, 3 cosine x times 3 to the minus cosine x, we get 3 to the 0, or just a 1. And then this, of course, is going to be just 3 cosine x here. But now I'm in good shape to actually add these two together. I can add the original integral, which I'll call I, and we'll call this integral I. And the reason I can do that, we're all in the same variable, and we've got the same denominator. I just reversed the order here, but that's the same denominator. So when we put these two together for 2i, let's see what we get. This is going to be just a 1 here. So when I add the numerators, we're going to get 1 plus 3 cosine x. And then our denominator, the same for both, is going to be 1 plus 3 cosine x. And that's why it works so nice, because then this whole integral just becomes 1. We integrate that. Integrating 1, we get x, evaluated from 0 to pi, but that's just going to be pi. But remember that we get 2 copies of the integral, so I need to divide off of 2 here, divide by 2 here, and then we get our final solution, just pi over 2. Okay, good problem. I think this makes it go a little quicker just because we don't have to do the u substitution. So we'll stop it there. Thanks everyone for watching. Have a great day.